Hi everyone, in this video I'm going to go through the Minimal Proxy Contract specifications of Ethereum, which is the EIP1167. Now before I go into this, I want to cover the upgradable contract pattern, which you see here. This is essentially where we have two separate contracts. One is for the data and one is for the application and business logic. And the reason for doing this is so that it makes the app contract upgradable. Why is this? Well, basically the app contract is deployed with an address that points to the data contract. So this means that if we want to upgrade the app contract, we can just simply redeploy a new version of the contract, such as v2 here, and point that to the same data contract. This essentially saves on things like data migration, which can prove to be a bit of a costly and difficult experience. So if we have this pattern, we're able to upgrade the app contract with ease. For example, if there is a bug that's discovered, or if the business logic needs to change, then any of that logic is in here and can be just upgraded as such. Now, the ERC1167 is different to this in many ways. So what we do is we start off with an app contract which has all the business logic in there. Let's say it's a wallet or an exchange, or any kind of app that stores data. And we're able to clone that contract into a proxy contract that can be used over here by this user. And this user makes calls through this proxy contract which they own, and the data is stored within this contract itself. So they own the contract and the data. And this is because the calls are made through a delegate call to the app contract. So the calls are done in the context of the proxy contract, which is why all the data can be stored here alongside the user and their own contract. So this is a very, very high level discussion and explanation of this. But the beauty of this is that this clone call here can be used to create as many of these proxy contracts as we need. Each one of them points to this app contract, and it is by far the cheapest way to be able to deploy multiple instances of a contract without having to actually deploy the full bytecode onto the blockchain. You end up deploying a very small amount of bytecode with the proxy contract, which saves you a lot of money in gas. So I'm going to go through an example now of how to do this. Okay, on to the exciting stuff now. I'm going to demo how we can use ERC1167 in our projects. So I'm going to be using Truffle for this. So if you want to install Truffle, you need to use npm and install and make it a global installation and type in Truffle like that. Now I've already installed Truffle, so I'll just show you my version of Truffle that I'm using here. And then we can get started. So the first thing we want to do is initialize a project. So I'll do truffle init, which basically will spin up a new project. Now it downloads a Truffle box there, and then we're done. Now I've already opened up the project over here. So we've got here a Truffle config as usual, contracts folder with migrations, and a test folder. We're not going to be running any tests or anything like that in this case, but what we do want to do is one thing, which is to open up this development network here so we can use Truffle console a little bit later on. Now, I'm going to start by building out a contract called store. So what I'm going to do is I've got the console open down here as well, this terminal window down the bottom. So I'm going to run touch contracts, and I'm going to call the first contract store. Then I'm going to open it up. And the first thing I need to do is write the pragma. So I'm going to use these shortcuts here provided by Visual Studio for Code. And I'm going to use 053, this is because later on I'm going to be using OpenZeppelin's version of the ProxyFactory for actually doing this. So then I'm going to write out a contract, and I'm going to call this contract store. And in this store, I'm going to basically just make it very simple, because I want to demonstrate how we can have proxy contracts as shown previously. So I'm going to just have one value called which is going to be a string. It's going to be public, and it's going to basically just be a value called value, right? And then I'm going to just provide a function that will set the value to a new value, right? We need to use call data, and we'll just pass in a new value here. And this is an external function, and basically we just set the value equal to the new value. All right, so that's our contract. That's a very, very straightforward contract. Now the next contract I want to write is the factory contract. So I just type here store factory and open it up right here. And then in this contract, what I'm going to do is use OpenZeppelin's ProxyFactory, and I am going to also actually sort of make use of cloning the contract. So actually I want to go back to the console here and install OpenZeppelin upgrades. This is the package that I'm using to make use of the ProxyFactory. So I'm just going to install that. Now while that's installing, I'm going to head back over here again. And what I'm going to do is I'm just going to import that into my contract. And of course I'm going to put the parameter here at the top as well, which I need to do for all the contracts that we write. Okay, cool. Now let's create the contract itself. So contract, I'm going to call this a store factory. And we're going to basically inherit from the ProxyFactory. So we're going to use the is statement, ProxyFactory. This makes sure that we get the functionality provided for us by OpenZeppelin. Okay, so let's just go straight to the clone function. I mean, we need a few other things like a constructor and a few other properties, but let's just write the clone function first, because this is the main thing we want to do. So I'm going to write a function here. I'm going to call it just clone store. And it's going to, it's not going to take any parameters, because we're going to need the address of the implementation of the store, but we'll pass that in the constructor. So let's actually do that right now. Let's create the constructor, because we do need the implementation. So if I type constructor, and we're going to have an address, which is going to be the implementation, and we're going to set the implementation to the passed in value. Okay, and actually this will be address. Okay. All right, and then up here we have address, public, like that, and now we can use it here. But the question is, like, what is the method that we should call? Well, the answer is, if we take a look inside node modules and we look inside Zeppelin, OpenZeppelin, we should be able to see the contracts if they've installed, which they almost have. There we go. All right, that's that. So if we go over the node modules, OpenZeppelin contracts, upgradability, you can take a look at the ProxyFactory that I'm going to be using. And the function that we're interested in is this one, deploy minimal. And you can see that it's been adapted from this repository here, the clone factory, from optionality. But I'm just going to use this one because it's basically uses node modules, and we can basically make use of this proxy created event in a second. I'll show you how. So let's call the function deploy minimal inside this function here. So deploy minimal, and it takes the address. Now, just have a look at this function again. You can see that it takes the address and it takes some data, and this data is used here to essentially to initialize the contract. Now, in our case, we don't have any initialization to do, but if you did, you would pass in the data here so that it would call the initialization function. We're not going to do that, but we still need to pass something in, so I'm just going to pass in an empty string, essentially, which is basically an empty set of bytes, which works for us. Okay, now the other thing that I want to do is just add a little bit of checking to make sure that only the owner of this contract can clone the store. And so what we want to do is we want to make this a public method, but we want only the owner to call it. And I'm just going to basically set the address of the owner up here. So public owner. That will be set in the constructor. So owner, give the message sender. And then we need to write our modifier. Modifier, which is going to be only owner, right? And what we will do is we'll just say, okay, require. We're going to require that the message sender is equal to the owner, and just say only the owner for this function. Alright, and then we put that there and that there, and so that should do it. So we have this only owner modifier, which is applied to clone store. Clone store calls deploy minimal, and I think we're good to go there. Now, the last thing we want to do is we want to add a migration here. Okay, so I'm going to just touch that, and it's going to be, we're going to call it, just call it to_deploy contracts. .js. Okay. Now, I've already written this, so I'm going to just basically copy and paste it into here, and I'll explain what's going on. So basically, what we need to do is, because the store factory requires the address of the store implementation, we need to deploy the store implementation first, which is happening right here, and then in a callback, we need to then deploy the store factory, passing in the store address. Okay, so I think that's enough for now. So we can head over to our console and clear that away. And what we can do now is we can start up Ganache. So I'm going to start up a Ganache CLI. That just basically is our local blockchain. So that's now running on port 8545. I can go to another console. We just go to this one here, and I can type in Truffle console, and this will open up a Truffle console session for us. So there we go. And then I can call compile, and this will compile our contracts, and that completed successfully. Fantastic. And then I can migrate them. So this migrates it to the Ganache locally running blockchain. That's great. And then what we can do now is we can try this out. We can actually experiment with this, right? So what I'm going to do is just grab an instance of the store factory, check that its implementation address of the store contract has been set correctly, and then I'm going to clone the store, and then I'm going to get an instance of the clone store and set the value. And I'm going to do this a couple of times so that we can see that the values are different. So I'm going to say store factory SF await store factory dot deployed. That gives me an instance of the store factory, and I can check the implementation address is the same address as the one deployed on the network. As you can see, it is the same for DA, and it's the store contract. Okay, so that's great. The store factory implementation address is set to the store implementation contract. So that's good. Now what we can do is we can try out the clone store. So I use the store factory and I call clone store like that, and we get a receipt back saying that it was successfully mined and everything, and we can see the event down here, proxy created. So that's fantastic. So what we can do now is we can make use of the store factories. We can use the get past events method, and we can grab the proxy created events from that. And you can see here that the part we're interested in is just here, the result. And in fact, in particular, it's this here, which is the address of the contract, of the proxy contract just cloned. I'll just flip back over to the code just to show you that in the proxy factory, the deploy minimal function emits this proxy created event here, which passes the address of the proxy contract to it. And you can see that the event here is defined here with one property called proxy. So that's what we're looking at here, is this proxy property of the event being emitted. So now we can create an instance of a store of this actual proxy contract by using the @ command here and just passing in the address like so. Okay, so and what I should have done there, I made a mistake. I should have put await here. Okay, so now I can check the value of this store. So we just do value, and you see it's an empty string, and I can set the value to my first store. Okay, and we can check the value again, and it's my first store. Fantastic. But now let's check that we can actually clone other instances of this contract. So let's clone a couple more. So we go back to the factory, and we're going to clone store, and we'll run it twice. I'll clear the screen here, and I'll grab the events. So get past events, proxy created. But this time we want to grab all of the events since the beginning of time, as far as this is concerned, right? So we want to get all the events from block 0, basically. So okay, so block 0, and what we should see are 3 events. Now, of course, I'm sure there's a better way of doing this, but I'm just going to grab the last 2 events because we've already got the first one. So it's the same thing. We've got the 2 results there. There should be different addresses, and they are. So this is the second one. So what I'm going to do is grab that address and say store2 is equal to store at this address. Make a mistake again. I should have put await. Let's do that. Alright, and store 3 is going to be this address here. So I'm going to get store 3 is equal to await store at store 3. Alright, so then we can set the values for store 2 and store 3. So my second store. Okay, and store 3 set value my third store, and I should put a capital V here. Okay, great. Now we can check the values. So store 1 value first store, store 2 value, my second store 3 value, my third store. So there we have it. That is how we can use the ProxyFactory from OpenZeppelin to use the deploy minimal contract, which is based on the clone factory, which is, of course, ERC 1167. So I hope that you enjoyed this video, and please come back for more. I'll be making more in the future and be making more frequently, so I hope you enjoy that.